are in Statistical Rethinking, second edition. We're in chapter 12, and we're on the hard questions. We're on question 12H4. Well, I guess let me say a couple things. So before you start, if you are going to use this code, make sure that you have installed and loaded the Rethinking package and stand, and you can do that with this first head of code blocks up here. Okay. And then the second thing to say is that 12H4 is the last of 4 questions that have been dealing with this data set called hurricanes. Okay? So if you haven't seen 12H1 through 12H3, you may want to go back and watch those. But most relevant here is 12H3, where in 12H3 we modeled the number of deaths produced by a storm as a function of the femininity of the name of that storm, right? So maybe Donna versus Andrew or something like that, okay? Where Andrew would be the more masculine name and Donna the more feminine name. Okay? And then we ran 2 models looking at the strength of the storm, and one of those, so one predictor that we used as a surrogate for strength of the storm was this variable called min pressure, and the other one was damage norm, which was the dollar amount of damage done by a storm. Okay, and so we had separate models for the 2 strength indicators, storm strength indicators. Okay, now it turned out that that between the 2 strength storm indicators, the indicator that worked better was norm damage. Okay, and this is a plot of the posterior predictions of that model, and here was a plot of the predictions for the min pressure model, where min pressure was an indicator of the storm strength. Okay, and you can just see visually here. You could also confirm it with WAIC or PSIS, which I believe we did in that previous video. But the damage is doing a much better job here of detailing the deaths, of modeling the deaths produced by a storm. Now, in that previous video, in 12H3 here, I did not actually use damage norm, but what I reasoned at the time was that probably the difference between $100 of damage and $101 of damage didn't make a lot of sense, and so we might want to work in orders of magnitude. So instead I took the logarithm of damage norm here. Okay, so what you just saw was exactly that. Okay, so here the damage norm is actually the logarithm of the damage norm, and actually, just to make it more complicated, it's a standardized version of the logarithm of damage norm. But now I wish that I would have read ahead a little bit, because this question 12H4 seemingly prompts us to use, instead of damage norm directly, to use log damage norm, basically for the same reasons that I was giving above as to why I use log damage norm. Okay? So this question, I think, assumes that in the previous question we used damage norm instead of log damage norm. So, so in this question, instead of using log damage norm, which I believe that the question is imploring us to use, we're going to backtrack and use damage norm instead, because again we've already used log damage norm, and then we're going to compare the resulting models. Okay, so so all of this preamble here is stuff that you've seen in the previous questions, 12H1 through 12H3. I'm just loading the data, looking at it, and now I need to comprise my data. So I have the same data that you saw in 12H3, except for I'm no longer taking the log of damage norm. Okay? And so now that becomes my data that I'm entering into the model. The model is the same as was in 12H3, m_b, but now I'm calling it m_b2, so that we can compare the 2 models. Okay? So this model has already ran, and I'll skip to the bottom here. So I'm going to compare the 2 models, MB and MB2, with WAIC and PSIS. and both of them, give basically identical results. But MB, again, the one that uses the log of damage norm, performs better than the one that does not use that does not use the logarithm. Okay, and that difference seems to be meaningful, right? Because the difference is about 40.5 points. Okay, with a standard error of about 14. Okay, so the difference seems to be pretty meaningful between these two models. Okay, so using the logarithm of damage norm seems to have been a good idea. And then just for a visual representation of how these models fit, I'm going to generate the same model that we saw above. I'm going to generate this model, but now for the non-logarithm damage norm. Okay, so just take a look at this image again, burn it into your retinas here for just a second, so that you can quickly compare it to this other model. Okay, so this is the non-log damage norm, and you can see that it does indeed seem to be having quite a bit of trouble fitting the data. And it also seems that it may be projecting really unrealistic death tolls. I mean, these values probably go up to infinity pretty quickly, much more quickly than we would want to be comfortable with. But yeah, but anyway, I think maybe we'll call that good. Maybe I should explain a little bit about this graph just in case you didn't watch 12H3. You can go through the code and decipher what's going on here. Okay, but all of the little points here are individual storms, and they are color-coded such that the more masculine the name of that storm is, the darker blue it is. Okay, and so there's, well, and then if you go the other direction, the more feminine the name, the pinker it is. Okay, and you can see that there's some scores that are kind of in the middle. There's some purple dots in here. Okay, and so those are kind of ambiguous names. Okay. So that's the actual data, and then we have the predictions of the model, right? So we took the bottom third of, we took the third most, how do I say this? We broke the names up in femininity category into 3 categories, from most feminine to neutral to most masculine. And the most masculine are is the blue air bars or air shadow here with a solid blue line. And then feminine is the dotted line, and it's pink, and then the ambiguous names are this purple area right here. So and so we can see 3 different levels of femininity names. Okay, but they all follow a similar pattern here. But okay, but anyway, the moral of the story is for this question that using log damage norm seems to be a good idea.